Hello and welcome to today's webinar. Thank you for taking time out and being here today. My name is Ayong. I am the Marketing and Educational Seminar Coordinator here at NeoBiotech, and this is me right here. Hello and welcome again. Today's agenda is very simple. I will introduce our topic and the presenter, and I will also make an announcement right after the lecture in regard to upcoming webinars and watch previous webinars and also how to receive your CE credits. So please don't leave and stay until the end. And let's also stay connected. Here is our social media page. Facebook is NeoBiotech USA, and Instagram is NeoBiotech_USA. And lastly, the YouTube channel is NeoBiotech USA right here. So stay connected and follow us, and we will share the most up-to-date our webinar courses and also our surgical kits as well. So our today's topic is the why guided implant surgery system is not working with Dr. Spencer Park. And we are also strongly recommended to use chat box to communicate with the host if you have any technical issues. And we will have a Q&A session at the end. So submit your questions through this Q&A box right here, and Dr. Park will answer your questions. So let's have Dr. Park to start today's webinar. Good morning, Dr. Park. How are you doing? Can you hear me?
Hello, Ayong. Thank
Hello.
you very much for your kind introduction.
No problem, always, doctor.
Yes, hello, everybody. Welcome to GAU and NeoBiotech webinars. Today, we're going to discuss about the CAD/CAM guided implant surgery system. Especially, I'm going to focus on the dark side of the system that we usually hide. So let me share my slide with you and let's start. So the title is a critique of currently available guided implant surgery system, efficacy, practicality, and limitation. In other words, I just want to share with you guys why our guide system is not working that we are expected. I've been teaching UCLA process for about 15 years, and then I've been involved several companies to develop their CAD/CAM guide system and also beta system too. And the NeoBiotech, it's been about 7 years for me to develop and then test their guide system too. So far we have a lot of guide system, right? It's been quite a long time. There's a lot of different company, and then each company claim that their system is best, right? And then very accurate, very easy, right? So no worries, something like that, right? However, the truth is that it's been more than 10 years since CAD/CAM guided surgery system was introduced to our practice, but I really want to share with you where we are right now. Where are we now? Is it really reliable, right? How come some of my friends, they bought a big system with a lot of money, but they never use that in their practice after a couple of times? Why that really also happened too? I want to share with you guys. To do that, I want to go over very briefly about some terminology with you guys to discuss about the digital dentistry. First, we know about the CBCT, right? Basically, that is a three-dimensional radiograph, three-dimensional X-ray. So whenever we take the CBCT, it creates the file, DICOM files. So so CBCT, the difference between CBCT and then the conventional X-ray, basically CBCT is three-dimensional, but there's also a big difference. CBCT's dimension is very close to the real dimension. So in the PA, if you have 1 centimeter on your PA X-ray, it's not necessarily 1 centimeter in patient's mouth. However, in the CBCT, 1 centimeter is quite close to 1 centimeter in patient's mouth. So dimension and angle is very close to the patient's mouth. That's a big difference. And also in this day, we are using the intraoral scanning a lot, so-called digital impression. So whenever we're using the scanning machine, it creates the STL file, right? So no matter you are using the intraoral scanner or extraoral scanner, Whenever you're using the scanner, it creates a file, it's STL file. That is something you have to remember. So STL, those intraoral scanning is basically your impression. When you're using the arginate impression, we call it arginate impression. When you use a PBS, we call it PBS impression. For digital impression, we are using the pictures. So we are using a lot of two-dimensional pictures and composite and create a three-dimensional image. That is a photo impression. So digital impression is basically photo impressions. Right? And then now let's talk about the scan body. So when you have a conventional implant impression, we are using the pickup impression or transfer impression. Yep. So when you're using the photo impression, we are using the scan body. So basically scan body is a digital impression copying. As you can see over here, this is a scan body. When your scanner is scanned it, and then it creates this kind of STL file, and then your software recognize that pattern, and then it's going to tell you that, hey, this is a NeoBiotech IS34x10, something like that. So that information that the software using to identify the model and then the size of this implant, we call that is also libraries, right? So keep in mind. And also in this, there's some company using the X-ray as their impression method. So so-called X impression is also available, but still we have to see how the accuracy is going on. So consequently, when I talk about STL and then the DICOM file, I can divide this. So oral mucosa, above the oral mucosa, then everything above the oral mucosa is a STL file. That is an intraoral scanning, the result. And then below the oral mucosa, that is basically CBCT result in the DICOM file. So to have a complete digital information, we need information from the above the mucosa, and also we need the below the mucosa. So those two information, two three-dimensional information need to merge together. Then eventually we have a complete three-dimensional digital information. So we can use that information as surgery or prosthetics. So what is a digital implant dentistry? In simple way, all the digital is same. We need the input, right? In this case, we need the two basic ingredient, that is a DICOM file from your CBCT, and then the digital impression, that is your STL file. And in this, we are using the facial scan as STL file. So bottom line is you need a DICOM file and you need a STL file. Those are two basic ingredients for your 3D digital information. With these two input, and then your computer is processing it. So at that time, we are using the computer assisted design, so so-called virtual surgery and virtual the restoration, right? So through that, we make the surgery, we make the crown, right, on the monitor. Based on that result, we are printing out. That is output. That is computer assisted manufacturing, so-called CAM, right? So we can use a 3D printing or we can use a milling machines, right? Those are two basic two things that we are using in dentistry. But one thing you have to remember is even though this is input, processing, output, however, who is the operator? You. So at this time, none of the systems AI, artificial intelligence, is not reliable. So all those information and the surgical and the restorative, the confirmation need to be done by the dentist like you. Don't forget that. And also, I wanted to point out that even though this is digital, it has a expiration date. So, for example, if you took the PBS impression, right? Once you have a PBS impression, can you use 3 months old PBS impression for the new crown and bridge? That is not possible. Same thing. When you have those are digital informations, for example, CBCT or intraoral scanning, those information I strongly recommend you to using the within 2 weeks. I strongly recommend you to use a fresh ingredient. That is most important. And also, once you receive your guide from the lab tech or the company, please use that within 2 weeks. Do not keep those surgical guide in your drawer more than 2 weeks. The bottom line is all those resin going to begin to deform after 2 weeks. And also during that time, if you wait 3 weeks, 4 weeks, and then those bone can be changed or tooth position can be changed. Most of our implant surgery patients, they don't have a tooth. What that tooth is periodontally compromised. That means if we wait too long, then the tooth position going to be changed. Once the tooth position changed, and then our guide is not fitting very well. That's why always using the fresh ingredient, and then once you receive the guide, and then do the surgery as fast as possible. And also when you do the final impression with your photo, right, with the scan body, then make sure that that is your final impression using that only after your soft tissue and hard tissue is healing and moisture done. Same as when you do the previous impression, when you take the final impression, what do? We wait and we make sure soft tissue is all set, and then we make sure those bone is all set, then we take the impression, same thing. Photo impression, basically, you have to wait until all those soft tissue and hard tissue is healed and matured. Keep in mind. Now, let's go over what we're going to talk about today. Well, I'm going to go very quickly about the literature review, about the accuracy of the guide, and then I'm going to talk about the workflow error, and then I'll talk about how can we overcome this. So to understand how to evaluate the accuracy of the guide, right, those are a couple of things we have to remember. Over here, this is what we planned. This is actually what placed. As you can see, the degree angular difference between planned and then placed, that is alpha. And also we can see those vertical error, and also we can measure those lateral horizontal error. So those lateral deviation and then horizontal deviation and also those angular deviation is what we usually use to evaluate the accuracy of the guide. So for example, this is what I wanted. However, this is how I placed. In this case, the angulation error alpha is about 9 degree and the lateral deviation is about 1 millimeter. In this case, yes, the lateral deviation is about 1.5 degree. However, the alpha is about 19 degree. So clinically, those alpha is really big issue, especially in the clinic. Visual distal, we are doing okay. However, buccal lingual or facial palatal is a main issue that causes a big headache many times. So I wanted to focus on those alpha, especially for buccal and lingual deviation to prevent any errors. I'm going to go over that later. So in order to measure or in order to compare whether your guide system is working properly or whether your guide is system is better than others, well, to do that, we have to follow a couple of steps. First one is position assessment. So in this case, over here, that X-ray is what actually placed. And then you can see those diagram outline is what we planned. So actually place the implant position need to be done, and then we superimpose, right, this thing actually placed and then actually we planned, and then we measure the difference that I showed you before. So based on those information, then we can tell before and after, or in other words, planned and placed, what we dreamed about it and what actually happened. Reality, we see the difference between. That's how we measure it. There's a many different way to measure it, but one way is those software, or sometimes we working those cast directly, or we can use intraoral scanning. So there is a 6 different way to measure the difference, but bottom line is, one thing that I want to point out is this: no matter what method we are choose, but that also depend on the accuracy of the CBCT and also the quality of your CBCT. And also, if you're using the intraoral scanner, that depends on the geometric accuracy of intraoral scanning image and also accuracy of imposition, how you merge those two images together. So the main reason that I'm explaining to you why, how to measure or how to compare those accuracy of implant guide system, because Main reason is that also depends on two things, CBCT image and also the accuracy of the intraoral scanning, and finally those superimposition. Those are three main factors that also determining the error of our actual implant placement. Let me go over the recent article about the accuracy of the guide. This article, they went over 3,000 articles and then they're using the 24 studies. So first one that I want to share with you is this. When we compare with the freehand and then full guide surgery, definitely full guide surgery is much accurate. So the error is much smaller. So there's no doubt, guided surgery is much better than freehand. Yep, no doubt. How about within the full guided? What is the error? They say this entry point is about 1 millimeter error average, and then angular is about 3.6 error. So what they're saying is, if you're using the tooth bone, tooth supported guide, that is most accurate. And then if you have a tooth mucosa, less accurate. And if you have a mucosa, is less accurate. And then if you put on the bone, it's a mucosa supported or bone supported, has a lowers the accuracy. And also if you do the flemish surgery, if you then you have a better accuracy than flap raise surgery, right? Those one thing that pointed out. Another one is this: when they calculated it, and then they also point out the average of the deviation. What they're saying is this is average. However, the range of the error is maximum is about 4.5 millimeter. In other words, the horizontal deviation is 1 millimeter. However, even though we are using the guide, it can be 4.5 millimeters. Apex vertical position also can be, the error can be 7.1. And also angular average about 3.8. However, the error can be 21.16. That is the range of the error. How is it possible, right? Even though we are using the guide and CAD/CAM system, how is it possible you can have a 21-degree angulation errors, right? But that really happened. I want to share with you that aspect with you. Let's look at the other study. They went over 73 study, and then they find out that very similar situation. In this case, their angulation error is about 25-degree angulation. And then also you can see the entry point 6.5 millimeter, apex of 6.9 millimeters. And then at the end, what they're saying is, and current the guide system, if your safety margin is about 2 millimeter, that is good. In other words, you designed it and you planned it and then you placed it. So when you compare with those the one implant that you planned and the one you placed, if the error, linear error is within the 2 millimeter, that is acceptable. Believe it or not, that's the current accuracy of the implant, especially because of that angulation. In this day, new biotech system, we decrease about 1 millimeter. However, still we need to keep in mind, there is always safety margin, right? So in other words, our guide system is not like zero point 0.1 millimeter accurate in some way. I want to share with you that too. So let's look at the general workflow of the CAD/CAM guided implant surgery. Here, we took the CBCT, and sometimes we took the intraoral scanning, or we take the impression with the PBS, and then we do the extraoral scanning too. So basically this CBCT, we have a DICOM, and then with this scanning, we have a STL file. So this DICOM and then this STL file going to merging together. So we have a complete digital world, digital information. Based on that information, we do the planning. That is a virtual surgery and virtual restoration. Based on that one, we're using the 3D printing, or we can use a milling machine. So we can make the guide and prosthesis too, right? So in this case, once we make those guide from the 3D printing or the milling machine, then using that guide, we are using the actual implant placement. That is the simplified workflow. Then let's look at the CBCT. What can be wrong with the CBCT? First one is a patient movement. When patient took the CBCT, Usually it takes about 11 seconds or 15 seconds, right? However, depend on how we guide the patient movement can be big difference. Based on one study, the average movement is about 1.5 millimeter. And then even though we try not to move a lot, but once we breathe, and then we move about 6 millimeters. So as you can see over here, you can see the double image over here. That means your CB patient move while taking the CBCT. And also over here, occlusal view, you can see those double line over there. So it is very important once your assistant took the CBCT image and then make sure you confirm it. Or once your patient went to the image center and make sure that image is acceptable for your implant digital surgery too. Second thing is metal artifact. Nowadays, a lot of patient has a restoration and veneer and also zirconia, and also many patient has also existing implant. Whenever we're using the CBCT for those patients and our X-ray photon hit those metal and then zirconia, and they're gonna cause a backscattering it. So as you can see over here, any metal, including zirconia, cause the significant compromise of radiographical image due to the beam hardening, motion, edge effect, and scattering noise. Over here, as you can see in the small pictures, on the top pictures is original shape. This is a metal. But once the X-ray hit it, and then you're going to see this kind of image on your monitors as a result of your X-ray. Here, perfect circle become fat, and then three dot become three lines, and then you have a ring, but it become kind of the fat tires. So keep in mind, if your patient has a lot of those restoration, then your CBCT image is going to have a lot of noise, and also it's going to compromise the quality of the CBCT. In this case, it's actually my patient case, and the patient already have a two implant, and I took the CBCT. But as you can see, once the X-ray photon here, you can see a lot of those layer, right? Those layer is a backscattering it, and this layer compromised the whole bone around it, as you can see, right? So keep in mind. And also, we need to talk about the quality of the CBCT images. If you have a poor contrast like that, so I told you about we need to merge for the CBCT, the DICOM, and the STL file, right? That's upper world and underworld. When we're merging those two three-dimensional images together, then here, this is some example. Those yellow line is your STL outline, and then you can see those CT outline. So we merge together. With the software, it looks like they automatically fit very well. However, when I magnify those areas a little bit bigger, now you can see a little bit of the discrepancy. Those yellow line is somewhere between white and black, but I'm not quite so sure. So let's magnify a little bit. Now that is within the white. If once I magnify more, then you can see that those yellow line is basically arbitrarily drawn. So in this case, the CBCT's image is not really great. In other words, it has a poor contrast. Contrast means that it's a differentiation between black and white. If you see the air, it is black. If you see the metal, that is white. In this case, the tooth over here is white, and the air around here is black. However, over here, you can see a lot of gray area over here. That means the contrast with this image is really not that great. So you don't want to see those gray area because you cannot see the outline. So the poor contrast gonna result in the blurry outline, and then when you merging or when you superimpose two images together, then you don't know where is outline is, so then it's gonna cause a error too. Many times this thing happen, however, lab tech did not tell you exactly, so they just arbitrarily doing that one. So it is very important for us to check our superimposed image before we processing it. And also, I'd like to point out that the accuracy of those intraoral scanning. So this article shows in the accuracy of the intraoral scanning. So if you do the conventional way, and then if you do the intraoral scanning and three-dimensional reconstruction, What they're saying is if it's a single unit, right, then the error is a conventional is a 21 micrometers, 24 micrometers, and then digital is 61 micrometers. However, if in terms of the full arch, all of a sudden that accuracy, the error of the conventional PVS is a 63 micrometer, that is quite acceptable. However, our intraoral scanning model is about 135, that is not acceptable. So at this point, no matter what kind of system you are using, if you're using the intraoral scanner, if you're intraoral scanning one quadrant, right, straight linear position is fine, but if you're going to scan the whole arch, then keep in mind it can cause some error, especially when you make the curve, when you make the turn. So in the K9 and K9, when you make the two turns full arch, it's gonna cause more errors. So my recommendation is if you are using the intraoral scanner and then you are doing only one implant, then you don't have to do the full arch. If you do the full arch intraoral scanning, you increase the possibility of the errors, right? And also one of the article also showing up that the difference accuracy between the actual intraoral scanning and extraoral scanning. What they do is they're using the exactly same intraoral scanning machine, and then they scan the patient's mouth, create the 3D model. What they took the previous impression and then they scanned that model with that same intraoral scanner, and then they create the digital model and they compare it. What they found is if we do the intraoral scanning, actually the error is bigger, and then they point out that the possibility of those bigger error reason is, bottom line is, it can be because of the saliva and also light. Those is the main issue. Previously, we're using the powder a lot, right? Nowadays, the powder is gone, then now it is, many companies claim that it is okay. However, all those intraoral scanner is basically photo impression. So it's going to be determined by the light. So if any moisture saliva on the surface of the gum and the tooth, the whole image is going to be compromised. So I strongly recommend you to use a retractor and dry very well while you are doing the intraoral scanning. Your assistant dry, put some air on it and then make sure your teeth are dry. But in this day, COVID virus issue, so putting the air is a quite big issue. In that case, you might use the gauze and then keep those areas dry as much as possible, and then the scanning. That is my recommendation. Now, let's talk about those errors from the merging. When we do the merging over here, the merging means that we have a CBCT image and also we have an intraoral scanning image, right? As you can see, this is white part is a CBCT image, and then this part is your extraoral scanning image. As you can see, the same patient, but there's some difference over here, right? As you can see that, right? So if I modify the magnify, you can see the big difference. In this case, one of those images is wrong. Maybe our model scanning or intraoral scanning is wrong, or maybe my CBCT image is wrong. So it is very important for you to confirm it, right? So when those lab technician told you is ready to move on, and then you ask them to let me see those comparing merging images, then you can see you want to make sure that there is not a big difference. So over here, so when we merge together and occlusally, you can see the error over here. It ended up about 1.3 millimeter, 1.03 millimeter error. So those yellow line is your model, and then that X-ray image, radial image is your CBCT. The question is, how do we know that which one is right? Maybe your CBCT is wrong, or maybe your intraoral scanning is wrong, maybe your impression is wrong. How can you tell? There's no way we can tell. So unfortunately, when you're doing the digital impression or digital dentistry, when you have those errors, then you have to do all over again. So in this case, you have the CT taken again, and or you have to do the impression again. So that is the only way. So in this case, over here, tooth number 11 area looks superimposed very well. However, tooth number 7, as you can see over here, there is an error. So it's a seesaw situation. So that case, I asked the assistant took the CBCT one more time and then also take the model one more time. Then now I can see that the difference is quite similar, quite decreased a lot. So then I superimpose and you can see the difference is decreased a lot. So it is not really 100% the same. The main reason is this image is from your X-ray photon. This image is from your light, right? So the way we create those 3D images is totally different because the origin is different. So the physics is different. That's why there is always built-in error or original error due to based on the method of the scanning scanning those images and three-dimensional images. Keep in mind. Now this case, I comparing the intraoral scanning image over here, and also I'm comparing the CT. Now those yellow line is your intraoral scanning image, and then those one is your 3D X-ray, the CBCT image. So let's focus on here. I want to share this quick video clip with you guys. So when I move on, as you can see, those yellow line, we have some error. In the tip of the cusp, there's some error, 0.4 millimeter. If I move a little bit more, and then the tip of those incisors, we have some those 0.34 millimeter errors. So once we have a superimpose, and then if you have those 0.3 millimeter errors, right, then you already have a digital error. So you should not move on for the surgery or any restoration with this kind of errors. So as I showed you before, there is many errors can be happen while we are doing the merging. And then those merging is depend on the quality of your original image, and also it depends on your lab technician's technique. So they have to be more careful, and then we have to confirm it, right? So as I told you before, once we have those errors, then what should we do? CT taken again, impression taken again, model work again, was STL file again. Unfortunately, we have to eliminate those possible error by repeat one by one. Now let's move on to those printing issues or milling issues. So now you can see the video clip. As you can see, those guide is rocking on top of the model, right? So you do not want to use those kind of rocking the guide, because since this is rocking, it can be left side or it can be right side, right? So you don't know which one is right position. So that means it's gonna cause a big error in your implant position. Why that happened? Keep in mind, it's about tolerance. I'm gonna go a little bit deeper later on. Tolerance is basically gap between your guide and then tooth in this case. So depend on how you do it. Basically, you did milling it, or you do the different way of the printing. The error tolerance is different, and the minimum thickness is different. In other words, even though it's the same company but different lab, the result can be different, right? And then also even the different same lab, the way the machine depend on the machine, it can be different. And also when those lab change the material, also it can be different too, right? So based on this information, I'd like to recommend you to do that when you're using choose the lab, do not choose some cheap lab, okay? What I mean is we have some regular average price for those guide, but if one specific lab has a very, very low price for the one guide fabrication, that means they are doing the debugging while um, the they are basically testing their machine. When they are testing their machine or calibrate their machine, they do not want to waste of their money. That's why they get the actual patient case, and then they actually using that case to calibrate their machine, testing their machine. So that means we have a higher chance of the error in our guide. So bottom line is, do not use ridiculously cheap lab for the guide situation. Now let's talk about the possible error when we place the actual implant fixture in patient's mouth, right? I told you about the tolerance. In this case, the tolerance is a gap between the guide and tooth and also guide sleeve and drill or guide sleeve, hold and drill. The more component you're using, it's gonna cause you more error. Over here, that is a small tolerance, right? That is a large tolerance. Then you can say that, hey, why can't we make the real small tolerance for every the drill and every component? Problem is if the tolerance is too small, then intraorally when you place the drill, it is very difficult for you to get through because you have a very specific, very narrow window of the path of insertion. And also from the manufacturer's point of view, they have to have a really high quality of the quality control. But when you have those large tolerance, and then good thing is it is easy for you to go through, right? So you don't have to worry about the very narrow path of insertion. It's a very convenient. However, and also manufacturer point, it is they don't have to pay too much attention for those quality control. However, the main issue is this. When I started the guide surgery about 9 years ago, this is what I thought. There is a hole, there is a drill. So when I put it in, I thought, I dreamed it's gonna go always like that. However, because of those gap, it ended up like that. Well, also it can be ended up like this. So after a lot of trial error and the neo biotech, we developed those early engagement model. So before we actually drilling, as you can see over here, that the cylinder part is the engaging the sleeve, and then it gonna hold it. And then also many trial and error, and then we decide that about 49 micrometers up to 51 micrometers is most accurate. That is okay for the clinician can find the path of insertion. So with this, the improvement, so we create those situation. However, with all those effort, as you can see, there is also still error. So this is a built-in error. Keep in mind that built-in error is called angulation error that we discussed about buccolingual or facial palatal, right? Angular error. Keep in mind. And also, I'd like to share with this article. So mathematically, this article is evaluate all possible error when we are using those guide. So what they point out is if those guide sleeve length, and then clearance, and then total the length of the implant, those three factors actually determining the error. So in other words, everything goes very well, and then you follow that guide perfectly. However, simply because of those mechanical built-in error, you can have some range of the error. In this case, if you're using the 4 millimeter sleeve length, right, and then if you're using the 30 millimeter, and then the built-in error alpha can be above 5.8 degree. So I just want you to point out that because of inevitable tolerance, right? Because of necessary gap between component, there is always possible error. Keep in mind. And also, when I using the guide for first time, and then I thought whenever I have those the slippery angle there, it's gonna go through like that. But in reality, it's not like this. When even though I'm using the guide, I touch the bone, I pushed it, I follow that the slope, and then it ended up when I push in, all my guide is also moving because there is also gap between guide and then tooth, and then also gap between sleeve and those drill. So it ended up always like that, even though you are using the guide. So when those guide move, on top of the tooth, it's a very little, about 1 millimeter or zero point 0.5 millimeters. So if you don't pay attention to it, you cannot recognize it. So you have to keep in mind. So for example, this is a clinical case. I put some bone graft over there, and then I make the guide plan. And then when I placed it, it ended up like that because my drill is follow those slippery slope, right? So how can we solve these issues? Well, one quick way, easy way is this. Before we do the point drill, make sure we do the bone flattening drill, like here. So we make the bone flat little bit, and then when we touch the first point drill, there is a no slippery bone existing. So then we can reliably touch the same spot again and again. So this is a very common sense. However, believe Buana, it took about 4 years to develop from left to the right side. Okay, so now, I strongly recommend you to every case, I strongly recommend you to use a bone flattening drill and then try to avoid the slippery bone situation. So you make the point drill contact is always flat. And also in this situation, right after the extraction, sometimes we want to put the implant. And then many people, many doctors point out that we need to using the septa as much as possible. So this is what I dreamed about, right? I go through the drill hole on the septa with a fissure, what a round bore, and then I place the implant like that. Even the guide, we are using the same dream about it. However, this is also happening, even though you're using the guide. And your guide is going to be, in this case, is tilted a little bit. In this case, even though using the guide, your implant placed in a wrong position. So how can we solve it? Same situation. The first contact point of your first point drill need to be flattening like this. In this case, we are using the bone flattening drill and make the septa is flat, and then we place the first point drill and then make the first hole. So if you ask me what is the most important drilling sequence of the implant placement, then I definitely tell you that this first point drill, okay? Once those point drill is wrong with the guide system, it is extremely difficult to fix it, right? So if you, when you do the guide surgery, you have to pay full attention when you do the first point drill. Once you have a good point drill position, it is very difficult for you to make the wrong or inaccurate position. So everything determined by your first point drill. Now let's talk about the anterior case over here. Even though we are using the guide, when our buccal wall is very thin, right? So here, this is what we dreamed about, what I dreamed about. But in reality, when I placed it, basically our osteotomy size is smaller. So there's always force from the palatal area. When I press it, it can go like that. Or if I didn't pay attention to it, then basically whole force from the palatally pushing my implant buccally, and then I ended up breaking those buccal wall, right? And then my implant going to be in wrong position, as you can see over here, right? This is why anterior implant is difficult. This is why you really want to use a guide for the anterior case. But this is why you have to be very careful when you're doing the anterior surgery, even though when you are using the guide. So when you are using the guide for the anterior case, then do not make your guide short. For example, if you are using the guide if you're using the guide for the tooth number 9, the placement, do not make your guide short. For example, tooth 8 and 7, don't do that. Usually my recommendation is at least 6 to 11 or premolar to premolar. Make sure your guide is big and then very retentive and then very stable. So when you have a very stable guide that covering your at least canine, and then you place the implant on the tooth number 9, they're going to they're going to provide the extra support that cancel off the force from the palatal bone, right? Keep in mind. Now, let's just go over very quickly about the dynamic guide, or so-called X guide, right? There's another guide too, and then they claim that they are using the real-time, right, guide. But actually, their procedure protocol is very similar. They make those marker guide, and then they took the CBCT, and then they connect those marker to the tracker. So in this case, those tracker has a very specific pattern on it, and then the stereo, those two cameras capture the position, and then based on that one, they can see where those handpiece going on and also where the bone is. But all those procedures also depend on the quality of the CBCT, right? And then also it depends on quality of the superimposition. So even though they claim this is real time, but the origin is same. Everything is dependent on the CBCT image, and then the merging, the accuracy. And also the difference of this, we call this a dynamic guide. Dynamic guide means that it is basically, you can see your handpiece, the position in real time, but it gonna give you only guide. So in other words, let's go this way. In other words, hold on. Okay. In other words, those dynamic guide work as a GPS. So while you are driving, your GPS is going to tell you, the navigator tell you that move, turn left or turn right. So then based on that, the GPS or the navigator I follow, I drove my car. But sometimes, even though my navigator told me to turn left, I missed it. So the dynamic guide have the same situation happen too. So when you compare with the static guide and dynamic guide, the static guide is physically going to guide you, so you have to follow it. Otherwise, you're gonna fight, right? However, bad thing is if the preparation is properly done, you don't know what is what's going on under the guide, right? That is thing. So now, consequently, when I look back all those the possible error, then I can tell you what is a non-preventable, what is a preventable. So tolerance between those component and error, and then between guide and tools, there's always there. And also type of the guide. If you have a soft tissue supporting guide, for example, Oron 4, Oron 6, and then you are telling many the companies point out that they using the full guide surgery put on the soft tissue and everything is fine. No, the error is really high. So depend on the guide, soft tissue support or hard tissue support, or even your bone support, all those things, you have to consider that one too. Preventable one is when you are using the guide, do not fight against your guide because your guide is going to specific possible insertion. However, when we are playing it, when we place the implant, we have some the pattern or some the habit. So our handle gonna go like this sometimes. The implant hand, the motor, so the guide is supposed to be, there should go this pump action, but sometimes we're moving this way, then now you're going to hear a lot of the frictional sound. In that case, do not fight. So follow your guide, right? And also fabrication error possible, inaccurate data is also possible, inaccurate data merging is also possible. So bottom line is, even though it says digital dentistry, but this is a very labor intensive dentistry. So to make the digital information, human need to work on it, and also human need to confirm it. So in my lab, when we receive the data from the users who for the guide, and then the first thing what we do is we check the quality of the CBCT image, whether this CBCT image, the contrast is fine or they are moving or not, right? And then also once we receive the model, whether that is a photo model for the I-500, those extraoral scanning model or the impression model, still we look at the quality of the model too. So some doctors using the iGen impression and they pull the standards, I do not recommend it. So the quality of your impression is also very critical. Whether that impression is your photo impression, digital impression, or conventional impression. So I strongly recommend you to have a crown and bridge quality of the PBS impression for the guy, or I want to have a good intraoral scanning images for the STL files, right? So the good thing about the CAD/CAM guided surgery is basically it's a virtual restoration and virtual surgery. And then if we are doing ourselves, or if we are doing the surgery by consulting with a lab tech, then at least we know some idea about where those implants gonna go on. So basically, sometimes when we open the flap and then we find a big surprise, but in this case, whenever we do the CAD CAM, at least we already did some virtual surgery, virtual restoration, so there is a very little surprise. So it's going to give you a more predictable outcome, and also you can prepare better. And also, important thing is we can place the implant little less errors. But all those, the treatment planning is based on your determination, all right? So overall, where we are going, well, we try to minimize the digital error as much as possible, right? However, my personal recommendation is whenever we have a CAD/CAM system, then it is extremely beneficial for the doctors to ourselves. We make the plan, at least the prosthetic plan, and also I want you to very intensively involve with the treatment planning with the lab tech. So I wanted to check the step by step. It will not take that long, right? And also, I want our guide system is more correctable or remakeable on the chair side in the very near future. And also, no tolerance. I want to decrease the amount of tolerance as much as possible. And then also when I compare them with the metallic sleeve and metal sleeve, at this point, metallic sleeve is better. However, in terms of the technical difficulties, there's a many issue over there, but still those metallic sleeve is better in terms of accuracy. And then in the long term, I highly recommend you to use a milling system instead of the 3D printing systems, right? This one is basically all the company to work on it, right? The main reason is 3D printing is also causes some error. However, milling portion is if I combine together and then the milling has a less error as long as we maintain very well. And then eventually I would like to have the product that has some static and also those dynamic aspect together. So static guide gonna give you a physical guide, and also those dynamic guide gonna tell you where your drill actually position inside of the bone. So I believe very soon we have this kind of system that improved a lot, right? So that make our life is much easier, and then we can deliver the much better clinical outcome for our patients. All right, that is for my lectures. Okay, so now I have a couple of questions. So let me go over the Q&A. You guys. So first question is, Dr. Park, still PVS impression is better than intraoral scanning. Okay, it depends on the quality of PVS impression. But at this point, when you have a quadrant situation, then your intraoral scanning is compatible to the PVS impression. I cannot say PVS or your intraoral scanning is better than your PVS impression. But when you have a full arch, then your intraoral scanning has a less accuracy than PVS. However, the big difference is this. Whenever your quadrant PVS impression, the impression is wrong, you cannot fix it. You have to take another one. However, digital impression, you take the first digital impression, you find the error, then you can change it, you can add it, you can correct it, you can update it. So there is a good point and bad point for that one. But to answer you quickly, the easy answer is quadrant, PBS, intraoral scanning, both of them is okay. Full arch, be careful just using the PBS impression, using the intraoral scanning. Right? However, whenever you're using the ortho procedures, right, then ortho procedure, we make the invisible line, those things. The accuracy, we do not recommend, we do not need 100 micrometers, 200 micrometers. So for the ortho purpose, intraoral scanning, full arch is fine, okay? Now okay, so another question, when is next webinar class? Very soon, there are gonna be the more detail about the CBCT, digital dentistry, hosted with the Ray America in June. So very soon we're going to update those schedule, and then please check our website and also read our email, so then you can find out more digital and CBCT related webinar too. All right. And then another question is, So one of the doctor has their own the 3D printer in their clinic, and then they create the doctor create their own guide. It is okay. However, you have to keep in mind every time you print out, then how can you be so sure your printing is exact same dimension that you want? So for example, in the monitor, you said 1 centimeter the cubic, right? But is it really 1 centimeter cubic in like actual your um, result? Even though those software telling you that hey, there's a 1.1 millimeter accuracy, that is not true. The only way to find out the error is you're going to create, every time you print out, you're going to create the 1 centimeter, 1 inch cubic in the corner of your 3D printing plate. So every time printed out, then you're going to measure the cubic. So you want to make sure that my known dimension of the cubic is printed properly. Then you know that the guide is the correct. So I know many of my friends and many of you guys want to print out in your office directly, right? Just side. But overall, that is not really practical. If you are really on in the printing, and then you need to have some high level of the printing machine, and also the issue is the maintenance. Every time you do the maintenance means that first you need to calibrate, and then once you print it out, you have to change the supply. And then even though we are using the same 3D printing machine, but oh, someone told me that the 3D the supply, the ingredient is better, so you're using the different solution, then the result going to totally different too. So in the practical point of view, I do not recommend you to using the 3D printing your own. However, if you are really interested, then you can do that. But always keep in mind calibration. That is a number one issue. Okay. And then another question is, do you need a tissue punch, right? Whenever you're using the guide, you have a choice. If you have a proper of the soft tissue, yes, you can do the tissue punch, right? So you have a carotid tissue all around it. However, sometimes our tissue is really bad, right? So you have a position, you want to flap it, and then you're going to create some the carotid soft tissue. In that case, tell your lab technician when you are doing the planning, hey, I want to do the flap for this case. In that, then we're going to make your guide based on your surgical plan. So we're going to make flange a little bit short. So for example, you can flap it, you can open it, and then we can put some guide on top of it. So still you can put using the guide for your implant placement. However, you're going to do the flap surgery or all those soft tissue surgery too, even the sinus, everything is too. All right. Okay. So that is answer is possible, but please tell your lab technician your plan. How are you going to handle your soft tissue? All right. Yes, it's a very soon. I'm going to have. The question is, can we have actual digital dentistry webinar? Yeah, I told you in the June. There's 2 times of the webinar going to be ready. Most likely second week and then fourth week of the June is we're gonna totally focus on the digital and then the CBCT. And then I guess final question is, Dr. Park. My question is okay. So question is, how can we choose the cuff height of our stock abutment? Okay, so then you have to measure it, the height from the platform of the implant to the soft tissue. So platform of the implant to the soft tissue, not the bone. Then you have to ask yourself, where you want to put some finish line of your implant, the crown. One of the 0.1 millimeter below the gum or 0.1 millimeter above the gum or interchangeable. To be honest with you, after all those years, when I do my own case, usually I talk to my patient. In the posterior, people hardly see those areas. then I want my finish line 1 or 2 millimeter high. So I try to make sure the finish line is away from the gum, away from the bone, as long as patient is okay. However, anterior case is totally dependent on you and also emergency profile. So usually anterior case, I put about 1 millimeter below the gum or 0.5 millimeter below the gum. But that is also case by case. So answer to that is, first you have to measure very carefully where your fixture platform and then where your soft tissue ended. And then focus on the facial, right? That is more important. And then final question is, what guided surgical kit do you recommend? Yes, I am the president of Neobiotech USA, so I have no choice but to tell you that Neobiotech Navi system is best. However, if you're using the different system, right, then I want you to study it, right? And then if you have any more interest, and then you're more than welcome to join my another webinar or actual seminar for guide. And then we're gonna discuss about how can we test whether our protocol is correct or not. So Neobiotech, our surgical guide protocol, I made ourselves for the last 4 years. So for example, like that, you have a good Ferrari for the car, right? It's a really great machine. However, the protocol is needed. How to drive a car is really also important too, right? So that how to drive a car is about protocol. So each guide surgical kit has their own, must be their own protocol that is optimized the result based on their surgical kit. So one surgical kit protocol, I cannot use this one surgical kit protocol for every other implant system kit, right? Yep. So, but my answer is a Neobiotech Navi Guide. And then very soon, about 2 to 3 months later, I'm going to launch one show that we're going to have a Baro Guide that is a world first instant CAD/CAM chairside guide system. So when patient comes in, within 1 hour, you can make the CAD/CAM guide and you can place the implant. So I'm looking forward to have a chance to share those info with you guys very soon in the US. All right. Okay, so I guess I answer all my questions. Then Ayon, could you take over? And then thank you so much for you guys. And then your attention is great. And I really appreciate and then hope you have a great afternoon today. Okay, and then stay healthy and safe. Thank you very much. Ayon, please take over.
Thank you, Doctor, very much for your presentations. And I will right go into the announcements. So please stay connected with us on social media again. Here's our Facebook page is Neobiotech USA, and also Instagram page is neobiotech_USA, and also lastly, our YouTube channel is Neobiotech USA. So stay connected and share also our social media and also follow us as well. And if you are interested in taking our webinars, you can find upcoming webinars in our website at www.neobiotechusa.com. And simply just click the webinar at the top right here, and you'll be on our webinar page. And we have another webinar today at 2 o'clock Pacific Coast time on session 1 of planning and surgery for extramaxillary zygoma implants with Dr. Dennis Smiler. So also register for this course as well. It's today at 2 o'clock Pacific Coast time. We have also another great lectures coming up this week on Thursday. First one is the 11 a.m. in the morning. It's the session 2 of also the planning and surgery of extramaxillary techniques with pterygoid implants with Dr. Smiler. And the same day, Thursday at afternoon at the 2 o'clock with Dr. Mike Chen on fundamental of breech augmentation with GBR. So please also save these dates on your calendar, and all these courses are also first come first served basis. So register in advance and reserve your spot. And now you can also watch previous webinars on our website. if you have missed any of these great lectures, you can simply go back to our website and click on the previous webinars at the top. Then you'll be on this previous watching webinar page. And there should be more of our webinars, previous webinars on here. It's all free, so feel free to check on this page as well. And also, I want to say thank you again for those doctors who stayed until the end. And as part of our ongoing effort to provide a better continuing education courses, we would like to request your feedback via a short course evaluation. So one of our sales rep will email you this link. So once you receive it, please fill it out and submit your questions. And this course should take no longer than 5 minutes. It's very simple, and there should be more questions in the bottom. And for Dr. Park's lecture, the course evaluation form should be looks like this. And I will send your CE upon completion of this course evaluation. I want to say also thank you very much for participating in today's webinars, and we hope to see you again. I hope to see you at 2 o'clock's webinar again today. So please register for that webinar again at 2 o'clock Pacific Coast time. It's on the diagonal implant with the Dr. Dennis Smiler. If you have any further questions in regard to today's topic, you could also email to Dr. Park. If you have any other questions, then you could email me. Here's my email, ayong.chui@neobiotechusa.com. And also, if you have any questions on our webinar schedule, we'll announce it very quick. So please check our website, or also check your email, so we will send all these future upcoming webinar courses very soon. So please stay tuned on that one. And I also want to say thank you very much, Dr. Park, for your lecture today. And also want to say thank you all other doctors who joined this webinar. And we hope to see you again.
It is my great pleasure. So thank you very much.
Thank you very much, Doctor. And lastly, there is a question through the Q&A box. I just want to go over this. So the one of the doctors asked, when can you go over the Barrow Guide? As I think Dr. Park mentions within 3 months. So I hope that answers your questions. So thank you again very much, all doctors, for joining today's webinar, and hope to see you at today's at 2 o'clock webinar. And hope you enjoy your lunch. And also I will see you later. And thank you very much. And I will end this webinar right here. Thank you, doctor, and have a great day. Thank you. Bye-bye.